Everyone, I'm Moshwar. Today we are discussing about that the class 12 physics chapter number class 12 physics chapter number 5. In this lecture we will discussing about that the relation between the magnetic field and magnetic field intensity. Okay, so where see here there are the B and H are there. So see there are the B, it is a magnetic field, and the H is the field intensity are there. So see here today we are discussing about that. Then after we will discussing about the permanent magnet and the electromagnet. So see here, the importance parameters marked on the curve are saturation, induction, Vs. See here, these are the saturation inductions are there. So this is the saturation. Whenever it will be saturate on that time, it is a saturation inductions are there. Retentivity. See here, there are the B of R. So this much area, this much area, it is known as the retentivity. Okay, it is known as the retentivity. Then after see here the Br. See, B retentivity is Br, and the coercivity is the, see here, from this point to this point, this is our coercivity. The coercivity in the MH plot is called the intrinsic coercivity. MIC or MCI saturation magnetization is the structure insensitive properties, which is why property, while coercitivity is the structure sensitivity properties are there. Okay, how much sensitive are there? So coercivity of nanoparticle is different from that of bulk material. So there are the different materials are there. So here we have just to see here that we are in the our syllabus there are the not this much kind of that, but I just explain to you because in the future you are understand, you are known this thing. So what I just showing to you the name of that. Okay, not to so inform about that what is it, but just to see here there are the different, it is a hysteresis loop are there. So this is loop is known as the hysteresis loop, but this loop is very useful in the understood about the relation between the magnetic field and the field intensity. So it is a relation between the magnetic field and the field intensity of ferromagnetic material is a complex are there. So it is often not linear and it's depend on the magnetic history of the sample. So dissipate the behavior of the material as we take it through one cycle of the magnetization. See, this is the one cycle of the magnetization. It is increasing magnetizations, then it will be decreasing on that time. What will happen? See, there are the differences there. This is the path difference are there. It is a, see from starting from here, it will be reached at here on that time. It will whenever we are going to off or whenever we are going to reduce the magnetic field on that time, it will be not come in the same directions, but it will be going to in this directions and it reach at this point. So this is the hysteresis loop are the hysteresis loops are there. So see here, let the material be unmagnetized initially. We place it in a solenoid and increase the current through the solenoid. Okay, what is the this graph? Whenever the material be unmagnetized initially, so we place in the solenoid, increase the current through the solenoid. The magnetic field be in the material arise and the saturation as dissipated in curve. See here, it's arise and saturated at cow. See here, this is our cow. So this behavior represent the alignment and the manager of the domain until no further enhancement is possible. So it is pointless to increase the current and hence the magnetic intensity as beyond this waxed we decrease H and reduce it to zero. Okay, when it reduced to the zero, on that time what will happen? So at h is equals to 0 and b is not equals to 0. See here, there are the b is not equals to 0, but h is equals to 0, but b is not equals to 0. So then something is that. So this is represented by the cow A, cow B, B as 2. This is suppose we are considering at the A. So A, B cows. Okay. So see here the value of B at is equals to 0 is called the retentivity. See here at value of at is equals to 0, it is called the retentivity. See, this is the retentivity are there in the saturation. This is our saturation inductions are there. This is our retentivity of that. So this is our retentivity. Also, the domain are not completely redomized even though the external deriving field has been removed. It means there are the if we are removing this solenoid materials due to the solenoid, it will be not will be there are the something magnetic fields are there. So this is the it will be not be removed. So this current and solenoid is reversed and slowly increased. So certain domain are flipped until the net field inside the stand nullified. So this is represented by the cow. See here, cow HC2 here A. Okay, suppose here I have not written it, but HC2 A. So it will be gives us that the value of that. So our field inside stand nullified. This represent the cow HC2A and the value of HC2 HC2A, the magnetic field intensity H is called the corrosivity. Okay, so HC is the corrosivity of that. So figure in this figure C is that. So see here, as the reverse current is increased in magnetic, we once again obtain the saturations. Okay, it will be reached at here, and again we are increasing the current, it will be getting to the saturations current are there. So it will the cow CD, the cow HC2A, the cow HC2A dissipates these, so the saturated magnetic field of BS, okay, is equals to approximately there are the something values are there. So the next current is reduced. The next current is reduced and reverse cow reduce reduce this cow from this point to this point, so this point to this point, and against and the reverse cow here from this point to this BS. This is the our against this cycles, so the cycle repeat itself, not that cow b cow not that cow b see here our cow, this is our mu x, it is see here, it is our from this cow, it is our mu value of mu x. Okay, so does not retrace itself as h is reduced for a given value of hb is not unique but depend on the previous history of the sample. This phenomena is called the hysteresis, and the word hysteresis remain the lagging behind and not history. So this is our hysteresis loops are there. So the permanent magnet applications, a high corrosive value is usually desire another quantity mark is in figure permeability. Okay, see here permeability, the maximum and initial permeability measure as a slope of the line from the origin to point is also structure sensitive property. The field require bring form ferromagnet to saturation ms at room temperature is small. It kiloampere per meter, but further increase in the magnetizations would require much stronger field, and this effect is called the force magnetize. Okay, this effect is also called the force magnetize, and this is known as the hysteresis loop of that. So it is an effect of the external magnetic field on the materials. So this is there are the wow something is that what is that first of all is the saturation inductance ds, retentivity of br, corrosivity is sc, the intrinsic corrosivity is MIC or MCI is that, and also there are the something is that permeability of that. So see here now the preferential alignment of domain can be brought about by an external magnetic field is during magnetize the domain oriented favorable along the field directions grow at the expense of the unfavorably oriented domains. So this can occur by there are the two reasons are there. First one is the domain wall motions smooth or jerky, and by second is that by rotations of the magnetizations of of the domain. So then the external magnetic field tends to align the misoriented spin in the domain wall, leading to this displacement. This process can occur simultaneously as the field increases. So rotation of a spin is opposed by the increase in the anisotropy energy. So during the rotation, all spin need not be parallel to one another, and the actual pictures may be literal complicated are there. So see here, there are the domain wall and the domain rotations are there, domain wall motions, and this is our domain. So something is that there are the something is changing are there. So domain related to the mechanics operative during the magnetization process are there. So this is our basic phenomena are there. Now we will discussing about that the temperature is not there. Here this is our today's topic. So if you have any kind of problem in this lecture, then comment in the comment box. Okay, if any kind of doubt, then also you can comment in the comment box. Thank you guys, thank you so much.